A very good morning to all of you, teachers, students, and all those who are viewing the program. Today we have got our second session of trigonometric identities. We have already dealt with basic concepts and laid down the foundation for this topic. So now we are moving forward to solve sums on this topic. So let us see what we are going to do today. So the topic is trigonometric identity. Let us brush up. What are trigonometric identities? Trigonometric identities are equalities that involve trigonometric ratios and are true for every value of the occurring variables, where both sides of equality are defined. So this is what trigonometric identities are. Now, to solve the sums, we need certain tools. So the algebraic identities are also an important tool for solving them. So let us see what are the tools we are going to use. Number one, a plus b whole square is equal to a square plus 2ab plus b square. Next one, a minus b whole square is equal to a square minus 2ab plus b square. A plus b whole cubed is equal to a cubed plus 3a square b plus 3ab square plus b cubed. Next is a minus b whole cubed is equal to a cubed minus 3a square b plus 3ab square minus b cubed. So these are expansion which you have already done, but time to time we need to brush up whenever we are using. Even in higher classes, you'll find that we need to use these identities. These are very, very important identities. Next, we have got the difference of the two squares of two variables. A square minus b square is a plus b into a minus b. Next is a cubed plus b cubed is equal to a plus b into a square minus ab plus b square. And a cubed minus b cubed is equal to a minus b into a square plus ab plus b square. So I hope you have noted them down. So we need all these algebraic identities to be used for solving trigonometric identities. Now we come to some reciprocal and quotient relation of trigonometric ratios. So again we are brushing up with these. Cosec theta is reciprocal of sine. So we say cosec theta equals to 1 upon sine theta. Sec theta equal to 1 by cos theta. That is, sec is reciprocal of cos. Cot theta is reciprocal of tan. So we say 1 upon tan theta. And then a quotient we have tan theta is sine theta by cos theta, and cot theta is reciprocal of tan, so we have cos theta by sine theta. So these are again certain tools which we are going to use. Cosec reciprocal of sine, cosec reciprocal of cos, cot reciprocal of tan, tan theta equals to sine theta by cos theta, cot theta equals to cos theta by sine theta. Now some standard identities again which we need, which we have already proved earlier. So today we am just giving you the standard identity. Sine square theta plus cos square theta equal to 1, from which I can write also sine square theta equal to 1 minus cos square theta, and cos square theta equals to 1 minus sine square theta. Next standard identity is what? Sec square theta minus tan square theta equal to 1. And from this, we can write sec square theta is equal to 1 plus tan square theta. So what we are doing, just transforming from one side to the other. And similarly, tan square theta is sec square theta minus 1. Again, transforming the sides, we can write tan in terms of sec. So these are again standard identities. So there's one more. Compare this. So cosec square theta minus cot square theta equals to 1. And from this we can write cosec square theta equals to 1 plus cot square theta, and cot square theta equal to cosec square theta minus 1. So we have got all these standard identities. So we have got all our tools beside us to do the sums. Now, today's lesson, what do we have? This is our second module. First, we are discussing points to remember while proving an identity. What are the points we need to remember when we go on to proving an identity? Next is using the basic identities to prove other identities. So, basic identities means the standard identities. Different examples on proving identities by inculcating thinking process. So, we are going to see how we can solve and how our thinking process can be developed so as to solve the sum. Next is proving trigonometric identities by different methods. So we are going to learn proving a particular sum in different methods. So let us go on to it. Now, first thing we said, what we'll do, we'll look into the rules to prove trigonometric identities. So these points you must remember. Follow one step at a time as I go on explaining. Number 1, first and foremost is copy down the full identity given. We find students, what you do is you just copy down the left hand side or the right hand side, whichever you are starting off, and then you don't have what you are proving at. Now, you must always keep the full sum in front because you must see what you are aiming at, what are you trying to prove. So that must be in front of you. Only then it becomes easy to prove. Remember this first step. So the moment you get a sum, take down the full sum. Number 2, now when we have an identity, we know it's an equality. We've got a left hand side, we've got a right hand side. So start from the complex expression to prove equal to the simpler expression. So you look at your sum, analyze which is looking more complex to you, and you start from that side. Number 3, do not try to prove the identity by transforming terms from left hand side to right hand side or right hand side to left hand side of the given identity. Do not change the identity. Keep it as it is given. They've said prove this is equal to this. So you start from one side and go to the other side. Next is do not square both sides of the identity to remove the square root sign. So when you see a square root sign, don't think that I'll first square it and remove it. Don't do it. I've said keep the identity as it is and then work on it. So do not square both the sides and do the working. So next is try proving the identity from one side and show equal to the other side. So you start from one side and go on to the other side, whichever side you would like to do. Now, next is the 6th point. The identity must not be proved by working with both sides together. Do not, right, left hand side, this is equal to this is equal to this. You are supposed to prove this is equal to that. So you don't go on doing both the sides together. Please remember this. So start from one side and go on to the other side. Next one. Now you're looking at a sum, you have got a sum and it looks that both the expressions are complex. So if both sides of the expression is complex, then what do? Then you may start from one side, say the left hand side, simplify as much as possible, and then work with the other side, say the right hand side, and hence show that left hand side equal to the right hand side. Use the standard identities wherever applicable. So that is a big tool for you to solve the identity. So you keep in mind what are the tools and then use the tools. Next is Use algebraic identities to simplify your result and prove the identity. So you can use your algebraic identities also to prove them. You will find out as we go on doing the sums. And the last point here we have, most identities may be solved by changing all terms when sine and cos. So you can always solve your sums by using sine and cos. So I hope the points are clear, and let us see how we follow these points to prove the identities. Now we are going on to solving the trigonometric identities. Sum number 1. Example 1, we are going on to this. Now the sum says, look at the sum. So we have got both the left hand side and the right hand side. So 1 plus tan square theta equal upon 1 plus cot square theta equal to tan square theta. Now see here, the right hand side looks simpler because it's only one term. So we are going to start with the left hand side. So method 1, let's see first method. So what did I say? We'll try to see how many methods we can adopt to prove the sum. Now look at it, 1 plus tan square theta. Your standard identity, remember? So sec square theta equals to 1 plus tan square theta comes from your standard identity. Sec square theta minus tan square theta equals to 1. There we have got the numerator. Again, cosec square theta is equal to 1 plus cot square theta. So therefore, directly we are getting, very good. So I can straight away write 1 plus tan square theta equals to sec square theta. 1 plus cot square theta equals to cosec square theta. Now, we have done our reciprocal. Why do I need a sec square by cosec square? We still have to go to tan. So sec square theta is 1 by cos square theta upon cosec square theta is 1 upon sine square theta. So remember your reciprocals. So therefore, what are we getting? Sine square theta by cos square theta. So if I divide this, we get our sine square theta by cos square theta. So what is sine by cos? That is tan square theta. So we have got our value for the right hand side. So that means it proves that this 1 plus tan square theta by 1 plus cot square theta is equal to tan square theta. I hope that is clear. Now let us see whether we can prove it by some other method. Suppose you forgot your sec square theta equals to 1 plus tan square theta. Is there no other way I can do it? Of course we can do it. Now let us have a look. Now what did I say? We can always transform our terms in terms of sine and cos. So now what are we doing? We are writing 1 plus tan square theta is, tan theta is sine theta by cos theta. So tan square theta is equal to sine square theta upon cos square theta. And cot square same way, we know cos square by sine square. So now what am I doing? I'm transforming tan and cot in terms of sine and cos. Now let us take the LCM. So LCM is what? Cos square theta is the LCM. So we get there cos square theta plus sine square theta upon cos square theta divided by sine square theta plus cos square theta by sine square theta. Now what do you know? What is sine square theta plus cos square theta? 1. We all know that. So sine square theta plus cos square theta equals to 1. So what do we get here? So 1 upon cos square theta divided by 1 upon sine square theta. On dividing, it reciprocates and we get sine square theta by cos square theta, that is equal to tan square theta. So there we have proved the sum, method 1, method 2. Now suddenly it struck me, I think I can do by another method also. Let us have a look. You keep your thinking cap on also. Just see whether you can do by any other method. Now, let us try here. We've got some space here. 1 plus tan square theta by 1 plus cot square theta. I know another formula that tan, because we have to come to tan. I don't want the cot. So this is equal to 1 plus tan square theta upon 1 plus what is cot? Reciprocal of tan. So 1 upon tan square theta. So that is equal to tan square theta is the LCM here. That is our denominator. Numerator remains as it is. So we write here 1 plus tan, let me write this down, tan square theta plus 1. This is my denominator. Now what about my numerator? Numerator remains as it is. So what did I do? First I'm thinking what to do with my denominator. I took an LCM tan square theta. So tan square theta plus 1 is your denominator and the numerator remains as it is. So 1 plus tan square theta. So when we have divided by, what do we get here? 1 plus tan square theta into this tan square theta goes up. So as a whole, this cancels off. So I'm left with tan square theta, which is what we had to prove. So there you've got a third method. With one sum, there are 3 methods to work out. So isn't it lovely that we can do by any method we want to? So whichever strikes. The first one, what happened? We used our formula because sec square theta 1 plus tan square theta struck me. It didn't strike me, so we went to sine and cos. Next, that also didn't strike me. I knew only that tan is and cot are reciprocal of one another. We use that. So we solved the sum with 3 methods. So one way or the other will strike you and you'll be able to always do the sum. Now let us go on to the next example. Now here we have got square root of 1 minus cos A by 1 plus cos A equals to sine A by 1 plus cos A. This is an ICSS sum of 2000. Now here you have got a square root. Now you have a tendency of squaring out so that work becomes easier. No, we are not going to change the identity. We'll keep it as it is and work on it. So therefore, what do I get here? So here we have, let us go on to the sum. Now I multiplied by 1 plus cos A into 1 plus cos A. So you may ask, why are we doing this? Why am I multiplying by? Now I said what? Keep an eye on your right hand side. I've got 1 plus cos A, which is same as this denominator, but here I've got a root. So without a root for 1 plus cos A to come out, it has to have a square under the root. So I make it a square, that is 1 plus cos A into 1 plus cos A is 1 plus cos A whole square. So if I take the square root, I'll get my right hand side here. But I cannot just multiply the denominator by 1 plus cos A. We know in a fraction, if I multiply the denominator by something, we have to do the same thing in the numerator. So I multiply the numerator and the denominator both by 1 plus cos A. Now, what happens here? So the numerator becomes 1 minus cos A into 1 plus cos A is equal to 1 minus cos square A and 1 plus cos A whole square in the denominator. Now, 1 minus cos square A, again an identity here, is equal to what? Sine square theta. So here it will be sine square A, whatever the angle is. So 1 minus cos square A is equal to sine square A divided by 1 plus cos A whole square. So under root, now I've got both square terms. Very good. Now what we can do, we can easily get the square root. So we have sine A, square root of sine square A is sine A. Square root of 1 plus cos A whole square is 1 plus cos A. So therefore we have got our right hand side. So I hope you've understood and you've understood how to think about the sum. That is the main thing. So you must be able to think how we work with it. Let us go to our next example. Now, we have got sine cube theta minus cos cube theta by sine square theta minus cos square theta equal to 1 plus sine theta cos theta by sine theta plus cos theta. Now, both looks equally similar type of expressions. So what to start off? Okay, let us try. So without starting off and trying it out, you won't be able to decide on it. So let's start with the left hand side. So sine cube theta minus cos cube theta by sine square theta minus cos square theta. Please, some of you tend to cancel the powers. Don't do that. There's minus sign in between. We cannot cancel. So what we have to simplify. It doesn't fall into any of the standard trigonometric identities. So algebraic identity is my tool now. So what do I do now? I first put it in the form of sine theta whole cubed minus cos theta whole cubed sine theta whole square minus cos theta whole square. So that is in the form of a cubed minus b cubed. Here I've got a square minus b square. So here is my formula. For a recapitulation, write them down so that you remember what to use. And these are going to help. So these two algebraic identities will be helping us to solve the sum. So we apply that. So same way as we have got A is your sine theta, B is your cos theta. So we get sine theta minus cos theta into sine square theta plus sine theta cos theta plus cos square theta divided by sine theta minus cos theta into sine theta plus cos theta by using this. So the first one we are using this, second one we are using this. So here we have got this. Now let us see what are we getting here. Sine theta minus cos theta is cancelling off. This is cancelling off here. So here we are left with sine square theta plus sine theta cos theta plus cos square theta divided by sine theta plus cos theta. See, we have already got our denominator. Now we have to see how we can get our numerator. Now sine square theta plus cos square theta, I've rearranged and written it as sine square theta plus cos square theta plus sine theta cos theta. It's not very essential, that step. You can directly write it down because we know that sine square theta plus cos square theta is 1 plus sine theta cos theta. So we have got here sine theta cos theta and we get 1 plus sine theta cos theta by sine theta plus cos theta. That is our right hand side. So it is proved. See how algebraic identities help you to solve trigonometric identities. Now, next. Now, the same sum, we were thinking both looks complex, which side to start off. So, we started from the left-hand side, we proved it. Is it possible to prove from the right-hand side? Let us give a try. So, you must always try it out. Now, have a look how the thought process must come in. Now, you thought you'll start from the right-hand side. Now, I said, keep an eye on which side you are going to prove. Now, on the left-hand side, I can see sine square theta minus cos square theta. Now, again, algebraic identities, a square minus b square is a plus b into a minus b. So, to come to a square minus b, I have got my a plus b, that is sine theta plus cos theta. So, I need a sine theta minus cos theta. So, again, numerator, denominator, if I multiply by the same thing, the fraction does not change. So, I'm multiplying the numerator, denominator by sine theta minus cos theta. And we need a cube here. What is the numerator which we are going on to? That is our cube, sine cube theta minus cos cube theta. So, therefore, what do I get here? Sine a cube minus b cube is again coming to my help. So, a cube minus b cubed is a minus b into a square plus ab plus b square. Now, have a look. What do I have? I've got the denominator sine theta cos plus cos theta. and sine theta minus cos theta. So therefore, here to apply my cube, because I have to go to cube. Don't forget what you are aiming at. So in place of 1, I'm putting sine square theta plus cos square theta, and this sine theta cos theta remains. See, a square b square plus ab, and I've already got my a minus b. So sine theta minus cos theta, rearranging, we have sine square theta plus cos square theta plus sine theta cos theta. So therefore, and the denominator is coming sine square theta minus cos square theta. So this is same sine theta minus cos theta, just putting it in this form of the identity. You can directly do also. And we get sine cube theta minus cos cube theta in the numerator and sine square theta minus cos square theta in the denominator. So the particular sum could be done from the left hand side or the right hand side. The only thing is look at what you are aiming to prove and just go on one step at a time, and you'll find out that you are come to the answer. The best part of trigonometric identities is you know the answer, you know what you have to go to. So whichever way you are proving, logical steps given, you will come to the answer, and you know you are right. There's nothing to go wrong about it because you have come to the answer. Now let us see this sum. Our fourth example, prove that sec square theta minus sine square theta upon tan square theta equals to 1 plus cot square theta minus cos square theta. Again, looking at this, it seems both are complex. So we need to decide. You will decide and you can carry on with that step. Now let us try what to do. First method. We are starting from the left hand side. Sec square theta minus sine square theta upon tan square theta. So sec square theta, one tool, standard identity, is 1 plus tan square theta minus sine square theta upon tan square theta. Now we have on the right hand side, see, we have got 3 terms. So since I've got 3 terms, what do? I'm separating each term. So 1 by tan square theta plus tan square theta by tan square theta minus sine square theta by tan square. So tan square I'm writing as sine square theta by cos square theta because I need to simplify. What is 1 by tan square? Reciprocal of cot. You already know by this time. This cancels both of them. So we get 1 here. Taking the reverse, cos square theta by sine square theta. Sine square theta cancels off cos square theta. So what are we getting here? 1 plus cot square theta minus cos square theta, and that is our right hand side. So we have proved it. So we started with the sec square theta minus sine square theta, and we have come to the answer. Let us see which other way we. So another way of doing from the left hand side itself. So what we do? So I said we can do the sums by changing everything to sine cos. So sec square theta, reciprocal of cos, so 1 by cos square theta minus sine square theta. What is tan square theta? Sine square theta by cos square theta. So I've changed everything to sine and cos. So taking the LCM, what do we get? 1 minus sine square theta into cos square theta upon cos square theta, and we have got here cos square theta plus cos square theta upon cos square theta, and this is cos square theta by sine square theta. So this and this cancels off. So what are we left with? 1 by sine square theta minus cos square theta. So you keep an eye on your right hand side. So we haven't still got it. Now 1 by sine square theta, we don't have anything in the denominator on the right hand side. So we are changing that to cosec square theta minus cos square theta. Still, it's not in the same form as what we want, but we already know that cosec square theta is 1 plus cot square theta. So we replace there. There we have got the right hand side. See, we have got another method of proving it. So method 1 we have seen, method 2 we have seen. Same sum. Again, another method. Let us have a look. What else we can do? Now we are thinking of doing from the right hand side. So we have done two methods of left hand side. Now let us see with this right hand side whether we can work it. Because you thought that that term expression is more complex, I'll start from right hand side. So we have got 1 plus cot square theta. We can write it as cosec square theta minus cos square theta. Now, as you look your left hand side, you find there is something in the denominator. Now, how does that denominator come? So, you think that I have to do something about the denominator. Let us bring in the denominator. Again, the rule, if I multiply the numerator denominator by the same term, the fraction does not change. So, we are multiplying by tan square theta, both numerator and the denominator. What was the purpose? What was the thought that came into mind of doing this step? Is because I need a tan square in my denominator. So I've got my denominator. Now we have to see how we can simplify the numerator to get what is there on the left hand side numerator. So cosec square theta, we are changing to sine reciprocal 1 by sine square theta. Tan square theta is sine square theta by cos square theta minus cos square theta into, what is tan square theta? Sine square theta by cos square theta. Now, here sine square theta and sine square theta cancels off. So what do we have here? So this and this cancels off. So you are left with 1 by cos square theta minus here cos square theta and cos square theta cancels off. You are left with sine square theta. Now, what is 1 by cos square theta? We already know. Sec square theta minus sine square theta divided by tan square theta. So here we have proved by taking from the left hand side, right hand side, and have gone to the left hand side. So I hope you have understood. Another method, right hand side. So there are two methods. Let us see what we can do. Now, suddenly it struck you that cot square theta, I need a denominator tan square theta. Now, cot square theta is 1 by tan square theta. Why not try by that method? Yes, any method you approach. So, cot square theta, we are writing as 1 plus 1 by tan square theta minus cos square theta. So, now take the LCM, we get tan square theta plus 1 minus cos square theta into tan square theta. So tan square theta plus 1 or 1 plus tan square theta is nothing but sec square theta. Again, you know this. And cos square theta, we have sine square theta by cos square theta. Cos square theta and cos square theta cancels off. You get sine square theta. So therefore, what are we getting? Sec square theta minus sine square theta upon tan square theta, which is your left hand side. Isn't it wonderful? See, one sum we could do by 4 methods, and when you find a different method of working out, you'll feel the joy of solving the sum. So when now you try your sums, when you're doing a sum, and if it is not just one single expression on your right hand side or the left hand side, you can do by any method. Please try that. Don't think of only examination. When you're doing a topic, ask yourself, can't I do by this method? Why am I doing this method? Let me try this method. Which is the simpler method? All these things, when you give a thought to it, you'll find it works out wonderful. And you'll find the joy in solving a mathematics sum, whatever the topic is. So we have done with 4 examples, with different methods, with different thought process, with using different standard identities and different algebraic identities. I hope it is clear to you. And now we come to the assignment on identities. Prove each of the following identities. So the first, please take them down. Sin A by 1 plus cos A plus sin A by 1 minus cos A equals to 2 cosec A. Each one copying down, think. square root of 1 plus sine A by 1 minus sine A plus square root of 1 minus sine A by 1 plus sine A equals to 2 sec A. Next, cos A by 1 minus tan A plus sine square A by sine A minus cos A is equal to sine A plus cos A. Next one, sec square A minus sine square A minus 2 sine to the power of 4A by 2 cos to the power of 4A minus cos square A equal to 1. Next one, cot square A minus cot square B equal to cos square A minus cos square B upon sine square A into sine square B. Next one, tan square theta minus sine square theta is equal to tan square theta into sine square theta. Hope you have taken them down, and please do try keeping all the factors that I have discussed in mind and work it out. See how you solve your identity. And the best part, again, I'm saying, all the identities, you have your answer in front of you. So you know whether you have come to the right answer or not. Now, in the first session, we showed this diagram with our 6 trigonometric ratios. Let us have a look here. What are the trigonometric ratios? I've just put it in a pictorial form so that it helps you to keep in mind, because anything pictorial remains in our thoughts and your mind much more than just in words. So here we have got all the ratios: sine, cos, cot, cosec, sec, tan. Now I put it in some order. Now let us look here. What can we analyze from here? Tan, sine by cos. Cot is reciprocal sine, so it's cos by sine. Next, see here, sine and cosec. Have a look here. I'm putting it. Cosec is reciprocal of sine. Sine is reciprocal of cosec. So vice versa. So this two opposite ones is one reciprocal of the other. See our cos and sec. See, cos and sec. Cos is reciprocal of sec. Sec is reciprocal of cos. And look at this, tan and cot. Just an easy way to remember your ratios. Just think of the diagram and you remember. So tan, sine by cos, cot, cos by sine, sec, cosec reciprocal of sine, or sine reciprocal of cosec, and sec reciprocal of cos, cos reciprocal of sec. So now let us go on. We are coming back to those points that I discussed. Why? Because there I told you, I discussed those points, what we are going to do. Now that you have done the sums, we have solved so many sums, now is the time when you are going to analyze these steps once more. So what did I say? First and foremost is copy down the full identity given. So you have understood the importance of copying down the identity, because you are always looking for at the right hand side or the left hand side to see what you are aiming at. So next time, don't forget to copy the full sum down. Number 2, we were doing this step also, starting from the complex expression and going on to proving equal to the simpler expression. So that is what is our next step we should remember. Number 3, do not try to prove the identity by transforming terms from the left-hand side to right-hand side or right-hand side to left-hand side of the given identity. So we did not shift any of the terms from one side to the other, but easily we were able to prove each of the identity by different methods. Do not square both sides of the identity to remove a square root sign, if any. So we have done a sum where there was square root sign, but without squaring, we easily worked on the sum. So again, we are satisfied the point that is given here. Try proving the identity from one side and show equal to the right and other side. That means from left hand side to the right hand side, or right hand side to the left hand side. What was our next point? 6 point. The identity must not be proved by working with both sides together. So we have not done any sum, but we have proved the identities. So do not work on with both sides together. Please remember this point also. Now, if both sides of the expressions are complex, then you must start from one side, say left-hand side, and simplify as much as possible, and then work with the other side, say right-hand side. Hence, show that left-hand side equals to right-hand side. So, we have seen also when we were doing the sums, if both the sides of the expressions are complex, so we had sums like that. So even number 4, when you saw the example, you saw we could start from any one side and we done it, but it was possible to go to the other side, but we could have done it going simplifying as much as we can and simplifying the other also and coming to a common expression. Use the standard identities, trigonometric identities, wherever applicable. So we have used everywhere the standard trigonometric identities, right? Use algebraic identities to simplify your result and prove the identity. We have done fully throughout. We have used our algebraic identities as a tool for solving trigonometric identities. And most identities may be solved by changing all terms to sine and cos. So we have done this also. So we have done sums changing to sine and cos, and we have got the answer. So these rules, if you keep in mind, you will be easily able to solve the sums. Remember, it's the more you solve the sums, the more you are able to do it, and the more you'll be thinking of the different methods how you can solve this. So experiment it. If I have done by this method, let me see. If I have done by this method, would I get the sum? So when you're doing your topic initially, don't think of for the examination purpose. Just think of the joy of solving the mathematics sums. That means the identities when you're solving it. Just think, how are the different ways I can solve them? Now let us brush up. What all did we do today? Rules to prove trigonometric identities, solving trigonometric identities by different methods, using algebraic identities to solve trigonometric identities. We have done that. So we conclude, a big conclusion here. So we conclude that we can prove an identity by more than just one method as long as the steps are logically correct. So next time when you're sitting with your friend and your friend is doing one method and you're doing something else, don't think that you are going wrong. He's doing this way, that means I'm doing it wrong. No, you can be able to do, you must be thinking in a different way, and you're doing the sum. So you are also right, he is also right. So ultimately you will all come to the same result. That is either from the left hand side or the right hand side, or right hand side and the left hand side. So I hope this was a fruitful one, and please do the sums I've assigned, and also try out different methods of doing sums from the book when you are doing the exercises. If you have already done the topic and you haven't tried out by other methods, please try them out. Can I do by this method? Ask yourself. Your question should be why we are doing it, how we are doing it, what are we doing. So all these questions must be coming to you. Not will this come in the board exams or not. That is not a big question. The question is whether you are getting it and you have satisfied in your mind that why am I doing this? Why am I going on doing this this way? Why not in the other way? So this will, you find that mathematics becomes much simpler when these sort of questions come to your mind. Now let us see what questions we have today. So here is a first question. Prove that square root of 1 minus cos A by 1 plus cos A equal to sin A by 1 plus cos A. This sum I've already proved. This sum is proved by taking left hand side. Yes, right. I did only the left hand side. Good observation, I must say. How will we prove the sum from the right hand side? So let us see whether we can prove it from the right hand side also. So what are we getting here? Let us take a bright color. Now sin A by 1 plus cos A. So you are thinking, is it possible at all? Yes, why not? Now think. Look at your left hand side. Left hand side is square root of 1 minus A, 1 by cos A. So I need a under root. So this is a 1 plus cos A. I want to bring a root. Only to get into a root if this comes out as a square term, if it is a square term. I want a root, I'm just adding a root. How can I just add a root to the sum? I can't change my sum. No, I'm not changing the sum. I'm putting sin square A upon 1 plus cos A whole square. In algebra also we know, if I have A by B, I can easily write it as square root of A square by B square, vice versa. From this I can go on to this, from this I can go on to this. So this, if I simplify, I come back to my original term. Now why did I think of this? Because I have to get a root. My main aim is to how to get it within the root sign. Now let us see what we can do. Now look at the numerator again. 1 minus cos A, sin square A, what can I write? We know the formula, identity. 1 minus, this is 1 minus, so again we are doing 1 minus cos square A upon 1 plus cos A whole square. So what is that equal to? We still have got the square root sign. That is a good sign that we have got it. Now 1 minus cos square A, again our algebraic identities. A square minus B square is A plus B into A minus B. So we get here 1 minus cos A into 1 plus cos A. There we have got it. And here what does 1 plus cos A whole square means? It's 1 plus cos A into 1 plus cos A. Excellent. So one term cancels off. There we have got the left hand side. So I told you, you can think any way you want to. You will come to the answer because I know my answer. So I've got my answer. So that is equal to my left hand side. So from right hand side also, if you start the sum, you are able to do it. So I hope you have understood. Now let us see what is our next question. There we have got our second question. Prove that sec to the power 4 theta minus sec square theta equals to tan to the power 4 theta plus tan square theta. Can we prove this identity by transferring a term from left hand side to right hand side or right hand side to left hand side? I would advise you not to change, bring the terms from one side to the other. So then what can we do here? So let us write sec 4 to the power of 4 theta minus sec square theta. So that is our left hand side. Which side we have taken? You can start from any side because both terms seem similar. One is with two terms, here also two terms. So I started with the left hand side. So I'm taking common sec square theta. So what am I left with? Sec square theta minus 1. So what is sec square theta? Minus 1. Now we know that sec square theta minus tan square theta equals to 1. So this we already know. So we are going to use it. Now what are we going to use? We want to have my result, my right hand side is in terms of tan. So therefore, I want to change to tan. So sec square theta can be written as 1 plus tan square theta. And again, sec square theta minus 1 can be written as tan square theta. Open it up. Tan square theta plus tan to the power of 4 theta. Simple. So that is equal to our right hand side. So you can even work from the right hand side and go to the left hand side. So I hope it is clear. So without transforming any terms, you can work on the sum. Let's see what is our next question. Now this question, okay, let us see. How do we solve a problem like sine square a minus sine square b equals to cos square b minus cos square a, which involves two different angles a and b. So we have got here two different angles. Now let us start with the left hand side. Any side it can do is equal to sine square a minus sine square b. So we have got two different ones here. Nothing can be taken common or anything because I've got, but keep looking at your right hand side. I need in terms of cos. So let us write this sine square a. I can write it as 1 minus cos square a and minus sine square b. I can write it as 1 minus cos square b. That is equal to 1 minus cos square a minus 1 plus cos square b. So 1 and 1 cancels off. So we get here cos square b minus cos square a. So that is equal to my right hand side. So there we have proved it. So no problem, if we have a and b, we can work out the sum. Let us see our next question. Here we have our next question. As we have algebraic equation, do we have trigonometric equation? Yes, of course we have. Let us see how a trigonometric equation looks like. So as you have seen, we have also in the last class we have said what equation is. It's also an equality which holds only for some specific values of the equality, not for all, whereas identity is true for all values. Now, trigonometric equation for y'all, there are different ways of solving, but for y'all, all our values will lie between 0 and 90 degrees because that is the scope of your syllabus. So if I take, suppose, sine x equal to cos x and you are asked to solve, you can even, because you know your standard values of values, you can find it out. Now, how do we solve the equation? So this is an equation with a equal to sign. You cannot have any value put and satisfying the equation. So I write here sine x by cos x is equal to 1 because I've divided by cos x both sides. So I get here tan x is equal to 1, and we know that 1 for tan is what? Tan of 45 degrees. You have already done this. So my x must be equal to 45 degrees. That is solved. Now suppose I had an equation like this, sine square x minus 2 sine x cos x or we can take only, let us take this, any equation. I'm just taking one equation. So minus 2 sine x, let us write plus 1 equal to 0. any equation. So I've taken this in this form because I've done already this with cos. Sine square x minus 2 sine x plus 1. So you're familiar, a square minus 2ab plus 1. So that is sine x minus 1 whole square equal to 0. This is an equation. So if I put here, therefore, from equation, you know how to solve an equation. Sine x minus 1 equal to 0. Sine x is equal to 1. And when is sine x? Sine of an angle 1. That is when sine of 90 degree we know is 1. So therefore, x is equal to 90 degree. So that is done. So we have solved an equation also, trigonometric equation. Let us see our next question. Now, question is it correct to write cos A plus B equal to cos A plus cos B? No, dear, it's not at all correct. Now, you will say why? Why can't we write it? In algebra, we can do it. If we can open it, why can't we do it here? See, suppose I take A is equal to 30 degree and B is equal to 60 degree. Now, cos of A plus B. What is cos of A plus B? Cos of 30 degree plus 60 degree. So that is equal to cos of 90 degree. And what is cos 90? You know the special angle, standard angles. So that is equal to 0. Now let us see the right hand side. Cos of A we have taken 30 degree plus B we have taken it as cos of 60 degree. Cos 30 you know your value, that is equal to root 3 by 2 and cos 60 is half. So my result is coming to plus 1 by 2. So cos of A plus B, please note, is not equal to cos A plus cos B. So remember that, all of you. So let us see our next question. Okay, this is our next question. For class 9 in trigonometry, we had a topic on complementary angles. Will sums on that be asked in class 10 board examination? Yes, you have done the topic on complementary angles, and direct sums based only on the complementary angles won't be there, but the application will be there. That means you may need to use it in other sums, like in heights and distance. Often we need to use the concept of complementary angles. So it's application there, but no sums will be asked on direct sums on complementary angles. Next question. Okay, our next question. Whenever we use any algebraic identity in the solution, is it important to mention the identity which we have used? See, it is not essential, but whenever you are doing, if you write it down, first of all, you won't forget your formulas. Second of all, it's right in front of you. Like we saw when we're using our a cube plus b cube formula or cube minus b cube formula, since I've written it down, I'm being able to tally it with my trigonometric functions that we have and how we can apply. So it's better that you write it down each time whatever you are using. And at least even if when you're practicing at home, make sure you always write it down. Then you don't even have to think what the formula is and how to apply. Let's see our next question. Okay, this is our last question. Is it necessary to learn how to use trigonometric tables? Yes, it is necessary to learn how to use trigonometric tables. See, In your scope of syllabus, you have angles between 0 and 90 degree. Now, you have done just a few, those special angles, but all the angles in between 0 and 90 are part of it. So, we must know how to find those values also. So, according to your scope of syllabus, you are supposed to know how to use trigonometric tables. So, when you have sums in heights and distances, it's not that you only have sums based on the special angles. You can get sums which are other than the special angles. So please learn the tables, especially with sine, cos, and tan. Hope you've understood. Thank you very much. A big thank you to all of you. I hope it was beneficial, and please try all the methods I've explained, and hope the topic is clear to you. Thank you very much. Enjoy learning. Take care and stay safe.